Hi everyone, this is yours truly, Lady Emmanuel, March 20th, making part 4 of translation of the quadratic parent function. On part 3, we ended with number 6AB, and I was sharing with you guys that you were going to compare this information, which is g of x, that function, with h of x for number 8. What I want to do in part 4 is sort of go through 7A with you just as well. So I don't know exactly how many I'm going to do. I'm going to do some for you. But go ahead and write the parent function. You should almost have this memorized. Remember, when it's just x squared, that means all the x value, you're going to square it, meaning you're going to say negative 3 times negative 3. They will all be positive. So negative 3 squared would be 9. Maybe I should. 9, then negative 2 squared, 4, negative 1, 1, 0, 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. Okay, give me those values. Now, if you notice here, for our parent function, you have here x squared, okay, for your equation. Then you have x squared here just as well. So you have x squared, x squared. So therefore, I'm going to use the parent function to come up with the function h of x. So f of x is being used for this function. So all I'm doing, taking x squared and subtracting 4. So since I know what x squared value is, all I have to do to these values is subtract 4. So let's do that. And yes, you can do it in your head, if you will. So let's do 9 minus 4 would give me 5. 4 minus 4 is 0. 1 minus 4 is negative 3. 0 minus 4 is negative 4. 1 minus 4 is negative 3. Look, it start back repeating. That lets me know it's quadratic. Then we have 4 minus 4 is 0. 9 minus 4 is 5. Okay. So there we have our y value for the function h of x, and we have our y value for the parent function f of x. So let's graph this like we did 6a over here. So, plotting the point, going through this information for you, plotting the point. So we have here negative 3, 9. So negative 3, go up. You probably say 9 is not there, that's fine. Negative 2, 4. Negative 1, 1. We have 0, 0. 1, 1. 2, 4, and then we'll have 3, 9. Go ahead and sketch. Look, you see I have this negative 1. Erase this right here. I said negative 1, 1 earlier, but it's actually, there was 2, so it should be here. But you see how when you make a mistake, it's okay, you just correct it. Okay, sketch it. I know you guys, some of you are artists, and you're like, okay, I could do this better than Miss E. Baby, that's good for you, okay? Everybody's not gifted as an artist, and I am one of them. So let me go use the highlighter to highlight this parent function, and this parent function graph is y equals x squared. That's the quadratic parent function. Now, I'm going to graph h of x. H of x, here we have, I don't have 9 on, look, you see I'm about to use 9 instead of the negative 3 for the x value. Be careful about that. When you have 3 columns table, remember the x value, the domain is here. This is the range for the parent function. This is the range for h of x, okay? So my x negative 3, it is 5, so I'll come over here to negative 3, go up to 5. Then I have negative 2, 0, negative 2, 0. Then I have negative 1, negative 3, negative 1, negative 3, down here. Then 0, negative 4, 1, negative 3, so 1, negative 3, 2, 0. Then I have 3, 5. 3 and take it up here to 5. Then I have to try to sketch this so cute, guys. I love using guys. Guys, this is so wonderful. Don't you just love math? Of course, Mrs. Emmanuel, everyone loves math. You guys like, yeah, right, Miss E. I'm gonna use the highlighter so you can see the grasshopper stand out. It sort of just help to highlight it. And colors, the brain love colors. Okay, these little calm colors here. So this here is h of x equals x squared minus 4. And here we have f of x equals x squared. So we have our information here. We have graphed it. Now part B is doing the same thing. It's going through the same process as part B for 6. Okay? So here, I'm making sure you see it this time on part 3. I was down low. I was like, ah. Anyway, here we go for part B. The vertex for the parent function is that minimum here. So the minimum, both of these has minimum because they're open upward. So in this case, I'm going to put minimum so you can know that the vertex here, the minimum is 0, 0. For the lovely h of x, the minimum, it has a minimum because it's open upward. So that vertex here is the lovely, and I can look in the table really, that's okay, it's 0, negative 4. So the domain, guys, keep in mind when you're dealing with quadratic function, the domains, when it's open upward or downward and it has arrow, the domain will always be all real numbers. Some say x is the element of all real number. Here, x is the element of all real number. Okay, so what I want to do, I'm going to stop here on this part, and I'm going to make a part 5 because I don't want to rush through it, and the video going to cut off anyway because it doesn't go over 7 minutes. Guys, love you. I'm going to cut it off right here, and I'm going to make a part 5.